Hi, welcome to the Calculus 3 Vectors and Geometry of Space unit. And this is the second video for the lecture number 4, the cross product here. Okay, so on the first video about this lecture, we introduced the formula for the cross product and what is the purpose for the cross product. And then we have find the important formula is the cross product, and the length of the cross product will be equal to A, the length of the A, length of the B, and the sine theta here, right? So now today we're going to continue work these units here. So let me get out and let me continue here. Okay, so the previous video we stopped at here. We did several practice about how to do the cross product, the mechanical. How do we do that? Okay, so in the previous video, we introduced one kind of the very important formulas, and we did that is the A cross B is equal to the A and the length of A and the B and the length of and times the sine theta, right? Okay, so now we're going to take a look at what is the meaning of this one. So before, let's take a look, I think from the lecture number 3, we say for a parallelogram here, right? So we say the parallelogram, if this is A, this is B here, right? Then we have the diagonal here, right? So the two diagonals here. So the diagonals here, so we get by using the dot product, we get a very important formula will be the A plus B, the length square, plus A minus B, the length square, is equal to 2A square plus 2B squares here, right? So you'll be able to prove it by using the dot product. That means if this is a parallelogram, then the diagonal square is equal to, if you square the diagonals here, you may add them up, it will be equal to kind of, the side square, you add all the 4 sides together here. So this is kind of, like in the general situation. So if your parallelogram is a rectangle, then because of the Pythagorean theorem, that will work. But in general, the parallelogram is not a right angle. So this is the one we have when we did the previous, right? So we did the previous lectures here. So it's very useful. Now today we're going to take a look at the parallelogram also. So like now we're going to see how the cross product is going to give us the parallelogram area here. Okay, so the area we know, since we were in the geometry class, we know the area typical is for the parallelogram is the base, times the height, right? So the base here, so that means the area is here, right? So the base times the height. So the base is the A and times the height. Correct? That's how do we find the parallelogram formula, the area. So the height here, take a look at height is the one from here to here. You have what? You have the perpendicular, right? So you have like the perpendicular angles here, right? Okay, so now let's take a look here. So the height is here, right? So the height is here. So this is the right angle. If this is the angle theta, so I know this one here is what? So here we see the sine theta is equal to what? It's a hypotenuse, the hypotenuse B, and over what? Adjacent over the hypotenuse is B, the sine theta, right? So this one, the sine, that's what is the sine theta. And now that's why the height is here, it will be what? Will be the B and sine theta here, right? Okay. Okay, so here, let me clear out this a little bit. The sine theta, I should do like this. All right, so the sine theta is the height, right? So that's the opposite side of the theta. So it's the height over what? It's the height over the hypotenuse, right? So the hypotenuse here is b here. So that's why it's here. I kind of, okay, so the height is here, right? So this one, this is your height. So that's why the area for the parallelogram is equal to the base times the height. So it's AB sine theta. And from the video number 1, we know what is this one? This is the definition about A cross B, the length here. Okay, so this is another, very nice way to find the parallelogram, the area of the parallelogram. If you use the geometry way to do that, it probably takes, it will take you 3 or 4 steps before you can find the area, right? So the first you need to find what is the slope of this line. Then you need to find the slope of this perpendicular line. Then you need to find where is this line intersect. So it's kind of a lot of steps. So by using the cross product concept, you can find the parallelogram. The area is very easy. Okay, so the next thing here, we're going to talk about, we call it the triple scalar product here. So for the triple scalar product, so if you have 3 vectors, A1, A, B, and C here. Okay, so the first thing here, we said the triple scalar product is just you put A1, A2, A3, B1, B2, B3, C1, C2, C3, like a matrix, right? And then the determinant of this matrix is what we call it here. So this is what we call the triple scalar product. So if you use a cross product here, you can, so here you can say here, the A dot product B cross C, this is the definition we called is the triple scalar product here, all right? So now let's take a look, so now let's take a look, what is this triple scalar product here? What is the geometry applications here? Okay, so the geometry application, so we know how to do the rectangular prisms, right? So if you have a, so if you give me a rectangular box here, right? So if this is rectangular box here, so this is what we call this rectangular prism. So what do you do here? Basically what you can do is like you find the area of the buttons, right? So you find this area and then times the height. So also like in geometry, we know that in general, so this box here is kind of like this rectangular box. So you kind of push it. That's why we call this is a slanted box, right? So and this slanted box, we call it is a parallelepiped. Okay, so it's kind of like the parallel, like the parallelogram prisms, kind of like that. Okay, so then we do the same ways, right? So take a look here, we say the volumes here, right, is always be the area times the height. The area we prove from the previous, so we say this is the B cross C here. So this is the area of these parallelograms, right? Suspended by the 2 vector B and C. And now, I need the height. The height of the parallelogram is like from here is perpendicular, right? So here is the height here, right? This is the height. Okay, so this is my angle theta here, right? And then we know, the B and the C, so these vectors here, right? So this vector is the B cross C here, correct? So this vector is B cross C. So I need to find what is the height, right? So what is the height for the, for this parallelogram kind of the prism, or we call it a slanted box here. Okay, so the same way, if you take a look at this right triangles here. Take a look at this right triangle, the yellow right triangles here, right? So let's take a look at what we have. So we have a cosine theta is equal to what? Equal to the height and over hypotenuse. The hypotenuse is a here, correct? Okay, so it's a hypotenuse. So that's why the height here, okay, is equal to the a cosine theta, right? So that's why in here you have here that this is the height, right? So, and this is the area. So area times the height, right, is equal to the volume. Okay, now let's take a look from here to here. How do I get this formula to the A dot B cross C here? Okay, so in order to do that, let's kind of try to refresh our memory. Okay, so remember, like we talk about the dot product, right? So we say the A dot B here, right? So A dot B is what? We say is the A B cosine theta, right? So it's AB cosine theta. So here, take a look here, right? So AB cosine theta. So you can treat this whole thing is A and this whole thing is B, right? Right, so this or let's go backward maybe so we don't get match the notations here. So you can treat you can treat this is A and this is B, right? So we have B times A cosine theta, right? So cosine theta is the angles, right, between the A and the B cross C. So I know this one I can use dot product, right? So the dot product will be what? Will be A dot B, right? So will be A dot B cross C here. So that's how do you get this formula. So the A dot B cross C, this is what we call it is the triple scalar product. And this one we defined to be A1, A2, A3, then the B1, B2, B3, and C1, C2, and C3 here, okay? Right, so the two things we need to remember, right? So what is the first thing is how to find the area of the parallelogram by using the cross product. And then the next one here is kind of extended. So the how to find the volume of the parallelepiped. So it's kind of like slanted boxes here. Okay, so now let's take a look. All right, so let's take a look. Find the area of the parallelogram with the vertices PQRS here, all right? So because they give you 4 points, right? So I can say, okay, let's say, let the vector A is equal to what? I can say that the vector A is equal to the PQs, right? So that means you use the end point minus the beginning point PQ. So what we can say 7 minus 4 is 3. And 5 minus 1 is 4. 3 minus 3 is 0, right? So I know the PQ is 340. Then I can let another one here as in B, I can say is the PR here, right? So the PRs here will be 6 minus 4 is 2, 4 minus 1 is 3, 2 minus 3 is negative 1 here, right? So now we know by the theory, we know that the area of this parallelogram, so like we call this is a PQRS, area of this parallelogram will just be the A cross B, the absolute values here. All right, so now let's try to refresh the, use this opportunity and try to refresh our memory. So remember, we do these ones here. We put this IJ case here, right? You guys remember from the previous video. Then you put this is 3, 4, 0, and 2, 3, negative 1. Kind of Okay, remember? So now we take the first two columns out, ij out. So this is 3, 4. This is 2, 3. Then we do the cross product like boom, boom, boom. Then minus the red one, go boom, 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 right? So now, if you can use this opportunity to practice one more time to see you remember. So this will be negative 4i plus 3j and plus k. All right, so now I know the area will be the length of this cross product here. So this is a 4, negative 4 square plus 3 square plus 1 square here. And I got is the square roots of 26 here. Okay, so now the number 9 is here, right? So the number 9 is here. They say A is 131, B is 042, C is negative 2, 2, 3. I want to find A dot B cross C here. This is what we call it a scalar triple product, right? So basically what that means here, so you just put this is 131, 042, negative 2, 2, 3. So you just find the determinant of this matrix here. So we can do the same way. We put out the first two columns. Those is 3, 4, 2s, right? Okay, now let's try to do it one more time. So this is 1 times 4 times 3 is what is 12, and plus 3 times 2, negative 12. Okay, so 1, 0, 1 times 0 plus 0. Okay, and then go here, and then minus. So minus negative 8, right? Then here is what? And so here, this is a minus 4, all right? Am I right? So minus 4, okay? And what is here? So here is minus what? Minus 0. So if you kind of combine all of them together, what you have here, so this is boom, boom, cancel. So this is a negative, negative become positive. So the answer is 4 here. All right. So that is what that's what is, we put it a triple scalar product. Okay, so now if I have this volume of the parallel pipe, so I want to find the volume. So I know the volume of the parallel pipe is what? Is the length, is the absolute value of the B cross product, dot product B cross C here, right? So now let's do the same things here. So that means, so the A is here, let's put it into the vector format. It's negative 2, 3, zeros, right? Okay, so it's a negative 2, 3, 0. B is 4, 1, negative 1. C is 0, 6, 1 here, right? All right, then the same way, let's move the first two columns out. Now let's do it one more time, right? So maybe let's double check that we got all the number right. Negative 2, 3, 0, 4, 1, negative 1, 0, 6, 1. Okay, so now let's do this way. So negative 2 times negative 1 is what? Negative 2. Then here, oh, times 0. I love those times 0. Hey, this is times 0. Excellent. Then we go the other way. Hey, 0 again. So how nice. Okay, so this is negative 2 times negative 1 is a positive 2. So it's minus 12. Okay, so here, what is here? 3 times 2. And so it's a minus 12. Right? Okay, good. All right, so now you combine, simplify that. So what is here? So this is a negative 26, but in here the volume is equal to the absolute value. So it's the absolute value of negative 26. So it's a 26 here. Okay. So that is how to find the parallelepiped. And so parallelepiped, the volume parallelepiped is what we call it, the scalar triple product. Okay, so the last things here we're going to talk about is another physics application is torque. Okay, torque is, so what is the definition of the torque? Torque is the tendencies, the measure of tendencies of the body to rotate about the origin when a force F on a rigid body at the point. Okay, so like in here, you can think about it, you know, like in here, so this, you can treat it, this is like your doorknob, you know, like the door handles, right? So when you try to open it, so what do you do here? You push the, you know, you give a force here, right? So you give a force like the F here, right? So here is your force. You push the handle down here with the certain angles here, okay? So then you will twist, right? So like when you open the doorknob, right? So then you will twist the doorknobs here. So this is the torque. So this is the force. So the torque here we defined is the what? Because this is the what? This is like the perpendicular to the, you know, the R's and the, you know, the force, right? So the torque is equal to the R. That's what we call it is the position vectors, right? So it's very similar like the work we, you know, we did before. So the name is R cross product, right? The force here. So the magnitude of the torque is just equal to the length of the torque, the R cross product F. So you can use like is the RF sine theta here. Okay, so it's very similar like the, so like do you remember like in the lecture number 3, we use the dot product, right? So we use a dot product to find the what? To find the work, right? Okay, so we find the dot product here. Right, so that's what is the two different applications. So one is the work, one is the torque here. So in order to find the magnitude of the torque, then we use the cross product. I think for the people, if your major is a physics major, this is kind of like pretty straightforward, right? Okay, so that's it. That is for this videos here. So let's refresh our memory. So what we learned is the key part here. The key part here is how to find the area of the parallelogram. So this is the first geometry applications about the cross product, right? So the length of the cross product is the, you know, the area of the parallelogram. Then we also defined this, we call it a triple scalar product, right? So the triple scalar product is basically you put these 3 vectors components into a matrix, and then you try to find a determinant, right? So then the other things we said here is very important is we try to find the volumes, right? So we try to find the volume of a similar like this parallelogram prism, or we call it the slanted box, or we call it a parallel pipe here, okay? And so then the formulas here, it will just be the triple scalar product. Okay, so that's it. And then the last things here you need to remember is the cross product, the physics application is how do we calculate the torque. So torque is the force, you know, when you rotate your object, just like we said, you know, like you kind of put the door handles here. So when you try to push down here, and how do you, you know, the rotate the doorknobs? Or, you know, like you can think about this is the screw, you try to get it into the wall, and then you try to tighten it up here. All right, that's it. And so it's nice to talk to you, and hope that you get a pretty good idea about what is the cross product. So make sure you know the mechanical part, you know how to do the calculation, then also you know the geometric meaning about the cross product. That means it's the vector perpendicular to both vectors. And then the different geometry applications and physics applications here. All right, so nice talk to you. Have a good day. And so looking forward to talk to you in our next lecture, in our next videos here. Okay, bye.